This is a presentation about horizontal control. In horizontal control, we find the coordinates of points to be used later on as horizontal control points. How to achieve that? We have different methods, and these methods are listed here, but in particular today in this presentation we will be talking about trilateration. In this method, the trilateration, the horizontal control coordinates, which are the easting or northing of the points, they will be based or calculated from measuring distances on the network, only distances. So what are the measurements here? As we always summarize the properties of each method, the measurements, they are all the sides of the triangles that we have in this network. The control needed, like the control needed for the triangulation, it is a coordinates of a station. So we have one control station with known easting and northing and azimuth of a line. The difference is that we do not have a baseline. We do not require measurement of a baseline because we are measuring all the distances. In the triangulation, we measure all the angles. That's why we had to measure a baseline. So how do we do the solution? The solution here, it is done using either the solution of triangles or we will do it using these squares. The solution of triangles, it is lengthy and we have different solutions from different roots, and that's why we have a better method, which is the least square. We will be using the least square method to evaluate the coordinates of the unknown points. A requirement that we have to come up with initial values of those easting and northing of the unknown stations. In the old days, there was distance measurements and angle measurements. The angle measurements were much easier because we had to measure distances. If we want to measure distances, it would be over like long areas and all over the places like mountains and depressions, whatever. So it was very difficult to be measuring distances. So we used to prefer the triangulation over the trilateration. So we will measure in the triangulation, we'll measure one baseline and we'll do it accurately, and that was enough effort to be measuring distances. After technology have developed and the EDM machines like total stations or electronic distance measurement machines have evolved, so now it started to be the distance measurement is much easier than the angle measurement. So the practice started to go for trilateration more and more. But when the GPS evolved, which is a method of using satellites to determine the coordinates between the points accurately and effectively, so the measurement of distances and angles started to fade out. So triangulation and trilateration were retreating in front of the GPS measurement method. So as we said, distance measurements started to be much easier and we started to avoid measuring the more labor-intensive angle measurements. So what happened when we started to have the EDMs is that we had role reversal. So we reversed the role of the angle measurements. It was very important, and the distance measurement was hard. Now with the EDMs, the thing has reversed, and the distance measurement became easier, and the angle measurements, it became more difficult. Where do we use trilateration? We can use it in large areas, medium-sized areas, no problem with that. As far as we can measure the horizontal distances, everything will be okay. So if we are doing the measurements over a large area, that means the earth curvature will show the measurements, and we have to be taking care of the calculations of the earth method and adjust for it. The best way to demonstrate the solution using least square is through an example. The input for the adjust software, which we will be using to solve these networks, it has a format in a text file, and we will feed it to the program and we get the result. To start with this example, what do we have? We have, this is point H, which is a control point. We have its coordinate. What did we measure? We measured all the sides. And the sides here, this is regular hexagon, like it's all the sides, they are equal, and that's why we can use some symmetry in finding the initial approximations of the coordinates of the points. So what do we have? We have measurements of the distances, and we have here it's AB and BC and CD and DE and FG and GA. So these are these distances. They were 23.15, and the radial ones from H to B to A to C, these are HA, HB, HC, HD, HF, and HG. It was 23.26. So these are all distances. They are in meters. What else? Because we have one control station, we need the azimuth of a line. We were given that the azimuth of line GA is 6610. So 60 degrees, 6 minutes and 10 seconds. So this is the azimuth that we are given. Now let's start putting the things in the format for the adjust program. But before that, we need to know how to calculate the initial estimates. Actually, as we said, because of the symmetry, let's calculate two values. One is D1 and one is D2. And we'll show you how are we going to use that. H is in the center. We know its coordinates. So if we want to calculate what is D1, D1 from the symmetry, this is 9 degrees. So D1 equals half of the BC. BC is a measurement. So we take its value divided by 2. So D1 now it's 11.575. What about D2? If you take this right triangle, we have 4 is a measurement. D1 we just found it. So we can find this distance, and which is D2. So D2 equals HC square minus D1 square. So D2 equals the square root of HC distance square minus D1 square, and this equals 20.175. Let's go now for the estimation of the initial coordinate. Look at it. So what do we have here? For point A, easting of point A. Notice how is the coordinate system. The coordinate system is upside down, like it is rotated. So this is E. So now we have this distance from here to here. This is the easting of point. So point D and point A, they all have the same easting as point A. So EA is equal to EH, and it's the same as equal to 323. This is from before. This is the given values for the point H. Now what about the northing of point A? So from here to here, this is the northing of point H. Now, how far in the north is point A from point H? It is the distance 6, which is distance HA. So distance HA, you add it to the given coordinate, which is 112. This is given northing for the point H, and you add the distance, which is number 6, which is HA, and it is equal to 23.15. So this is the coordinate, n coordinate of point A. Let's go for point B again. Point B, it is, if this is the E axis. So if you add the coordinate, the E of point A, and you add to it the distance from here to here, which is D2. So easting of point B is equal to easting of point H plus the distance D2. And these are the numbers. For the northing, in the north, the difference between H and B is this distance, which is D1. So take the northing of point H, add to it the distance D1, and you will get the northing of point B. These are the numbers. The same way, either we will be adding or subtracting from the coordinates of point H, or and then if you want to make it easier and easier, the point B is on the same alignment eastwise with B. So once you calculate easting of point B, easting of point C is the same. Northing of point B, this distance is the same as northing of point G. So you can use the symmetry. And point C and point F, these are initial approximates of the coordinates. So you can just use these. So the northing of point C is the same as northing of point F. You can use that so you can expedite your calculation. So at the end, these are the numbers. For the format now of the adjust file, we have distances. The first thing, we have 12 distances. As you see from the numbering, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And we have 0 angles measured. We did not measure. This is trilateration. We do not measure angles. How many control stations? We have 1 control station. How many azimuths? It is 1 azimuth. How many control stations? We have 1 control station. So this is 1 control, which is point H. And what is the total number of the stations, including the control station? It is 7. We have 6 on the perimeter of the shape and 1 control, so the total is 7. So now we want to enter the control station coordinates, which is H, and then A, B, C, D, E, F. These are FG. These are the six stations, and these are the approximate in blue. These are the approximate values. Now, for the these are for the stations. What about the distance measurements? These are the observations of the distance. So as we listed that, we will list from B to C, from C to D, the distances, and we have plus minus 1 centimeter, which is 0.01 meter. This is the standard deviation. When it comes to the azimuth, GA, because we have one azimuth observation, it is from point G to point A. And from point A to G to A, we have the value from the north as 60, 06, 10, and plus minus 5 seconds. Now, enter that data file into the adjust program, get the result, go for the adjusted stations. The adjusted stations, these are the results. So we have for point H, this is what is given, and point A, point B, point C, point D, point F, point G, these are the calculated coordinates, and these also here are the coordinates, easting and northing, and we have the standard deviation of the easting and standard deviation of the northing for each point. And that's it. See, as simple as that. Now, what if we have this variation? Actually, this is example 2. I just put it here to give you an idea. From before, from the previous example, we had only one control station, which is A, and that's why we needed azimuth of a line. But for now, we have 2 control stations. We do not need the azimuth of a line, because from these 2 control stations, we can calculate the azimuth of line AH or HA, regardless. So here, if we are, what we see here, that because we put the northing here, it is, and this is the angle. What is this? This is alpha azimuth of AH. So when we want to put that as an observation, we do not need the observation. Alpha AH is calculated automatically from the 2 control points. So we do not need. So here we will have, if we want to do number of distances, the same thing. We have 12 distances, and the number of angles 0. The number of azimuths 0. The number of control stations 2. The total number of stations, it is 7. And we will not be adding at the end. We will not have azimuth observation. We will have just the distance observation, or at the beginning the coordinates of the control points. A, we will have A and the coordinates, and H and the coordinates. Then we will have the unknown B, C, D, F, and G, and we will put here the approximate coordinates for these points only, and then we will have the distances, and that's it. We do not have observation for the azimuth, because the azimuth, it is derived, or the known 2 points here, they will determine the orientation. We do not need the azimuth measurement. This is the end, and I just want to show you that the networks, they can come in different shapes, in different complexities, depending on the area it is describing. And I want to say there is nothing difficult. You just take it, what are the measurements, what is given, and you prepare the adjust data file, put it in the adjust, take it, and see the result. So this is the end of the chapter of horizontal control. I wish you good times in dealing with these problems.